Hey guys, this is Academic Chemistry, Chapter 3, Section 1, Measurement. So today we're going to be talking about how to take measurement. So a big focus of this is going to be significant figures, which you might have heard about if you have an older sibling that's in chemistry or a friend that took it before. I promise it's not as scary as it might have seemed. We're going to just walk through it real step by step. So how to take measurements. So before we get into sig figs, the number one most important thing is always put a unit at the end of your measurement. So you don't want any naked numbers. So let's look at what that means. So over here I've got a bunch of measurements and they're all dressed all nicely with, 0.75 meters or 6 milliseconds, 82 liters. So you know exactly what you're measuring. But over here, those are not good. I've got 1.6 times 10 to the third. What? Bananas? I don't know. Are those grams? No idea. So these are terrible measurements. They're not even measurements because they don't have a unit. They're not measuring anything. So you always want to dress your number by putting on its clothes, which is its units. When you're measuring liquids, always look to the bottom of the meniscus. So liquids have this fun characteristic that they are sometimes attracted to the glass on your equipment. So if you've got like a graduated cylinder and you're filling it with liquid, then that outside part actually gets pulled up by the glass because of those attractions. So it makes almost like a smile looking shape, as you can see right here. This is the meniscus. So you're always going to look to the bottom and take the measurement there. So when you look at eye level, make sure you measure at the bottom of the meniscus. So right here. Here's another picture. Remember, get at eye level. This does mean that you're going to have to bend over a bit in the lab. You don't have to fully get on your knees or anything. Just crunch over a little bit so you can look right at the liquid straight on. All right, so the last rule is that sig fig rule. So here we go. You're always going to estimate one digit past the smallest graduations on the device. So what does that mean? Well, let's go ahead and define a few things. So when you're taking a measurement, it's important to use the proper number of significant digits. So significant means important, and digits just stand for numbers, like 1 is a digit, 0 is a digit, 4 is a digit. You can also call them significant figures, saying each digit is actually a figure, and then that abbreviates to sig figs, which is how the cool kids talk about significant digits. So here are 3 measurements just to compare. I'm measuring the same bug right here. This one is 0.6 centimeters, this is 0.62 centimeters, and this is 0.628 centimeters. It's the same thing I'm measuring each time, but notice my measurement changes in the precision. As the precision of the measuring device goes up, the precision of your answer has to go up. So the more precise your measuring tool, the answer needs to reflect that so your reader knows how precise you used in your measuring tools. So the big thing is when you're taking a measurement, all the digits that are expressed are all known except the very last digit. The very last digit that you write down is always going to be estimated, meaning there won't be any graduations or tick marks at that position. So your known digits are positions with graduations, and graduations are those marks that are shown to take measurement on whatever your apparatus is, whether it's a graduated cylinder, that's where that name comes from. A graduated cylinder, as shown here, is literally a cylinder with these graduations on it. A ruler is going to have graduations in the centimeter and millimeter position on those meter sticks. So if I have this measurement, 21.6 milliliters, that comes from here, this liquid that I have in this picture. You look at the bottom of the meniscus, and I see that the last known place it hit was 21 milliliters. I got that because all my graduations are changing by a factor of 1. So I know that there's at least 21 milliliters. So I can say that this 21 milliliters is my known measurement. Then I always estimate one more spot. So this 0.6 is estimated. Someone else might take this measurement and say, oh, well, that's 21.8 milliliters. And that's fine because that last one is estimated. It's kind of like that eyeball. And it's not like in real life you can zoom in like you do on the iPhone. You just have to kind of eyeball and see it. I think that looks just above halfway between 21 and 22. So that's why I'm putting it at 21.6. Here's your rules for writing the right amount of significant figures, or sig figs. First thing, whenever you look at your whatever you're measuring, your apparatus, so whether it's a meter stick, a graduated cylinder, a beaker, whatever it is, you first want to see how do your graduations change. So are they changing by ones? Are they changing by tenths, hundredths, thousandths? How are they changing? Next, write down the last measurement that substance passes. So before, remember, that was our 21. That was the last graduation that it hit. And then you always add one more digit to estimate. The trick here is if it exactly hits at that graduation, add a 0 at the end. All right, so again, we're going to do the same example. First step, remember, is look at how the graduations change. So look at your numbers. I've got 5, 10, 15, 20, and you look between. So I have these 4. So this is 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. So I know that this is changing by my ones position. So my known digits have to extend to the ones position. So I'm going to zoom this in a little bit, and you can see that this goes right above that 21. So I know that there's at least 21 milliliters. So your known is saying there is at least this amount for sure, guaranteed. Then I'm going to estimate, and the estimation comes between the last graduation that it passes and the one that it doesn't pass. And see, this is just over half, so that's why in the 10th position, I put 6, and that's my estimated digit. So let's compare these again. Notice I have 0.6, so my estimated is this 6 here. Well, this ruler changes by a factor of 1, so I have to estimate at the 10th position. Versus this ruler changes by a factor of a 10th. So my estimated digit is now a 2. I know that this passed 0.6. That's now known because this ruler is more precise than my left ruler. So my 0.2 is estimated. Over here, these measurements are changing by the hundredth. So my 0.62 is known. That's that little guy right there. And the 8 is estimated. So when I have my estimated digit, at the thousandths position, it's because my ruler or graduations changed at the hundredths. When my estimated digit is at the hundredths, my ruler changed at the tenths. When my estimated digit is at the 10th, my ruler changed at the ones. So using the correct number of sig figs allows your reader to know exactly how calibrated the instrument was that you used to take measurements. So if someone saw this and only saw this center one, 0.62, they could deduce that you did not use the far left or the far right ruler because the far left is not precise enough and the far right would be too precise. So you would know exactly what ruler the scientist used. All right. So using those rules, I want you to freeze the computer here and try and write, what do you think this piece of marble shown, the length of it? And make sure you have centimeters as your units, because you always want to address with the proper units. So freeze the video, come up with your answer, and then we'll compare. All right, so I got for this that it's changing by tenths. This is 1.1, 1.2, 1.3, 1.4. So I know it's at least 1.3, so I have to write that as my known, and then I estimate one more. So these are examples of some possible measurements you might have gotten. 1.36, 1.37, that's what I put, or 1.38. Those are all pretty understandable units or measurements, and make sure you have centimeters at the end. Let's do one more. What's the volume of this liquid? Make sure you use the same rules. And also, you've got to write milliliters because you have to have a unit, and this is a liquid. You have to look at the bottom of the meniscus. So go ahead and freeze the video and then come back in a second and we'll compare. All right, so to me, this looks like it's right there at the 24. So I know it's got to be 24 milliliters, but 24 is a graduation. So I can't just put 24 and be done. I need to go to the 10th position. So since these change in the units position, it's changing by 1, 2, 3, 4, 5, then I have to have one more digit. So I call this 24.0 milliliters. it's saying, I know for sure there's 24 milliliters, and I'm pretty sure it's right on at 24. All right, that's it for today's notes. Make sure you email or go talk to a teacher if you have any questions, and good luck with the section.